Here's what you want. Here's what you got. You got your traditional Evinrude 1.87 ratio lower. It came on basically all your V6 models, your commercial V4 looper models, possibly even the commercial V4 crossflows. I'm not sure about that. But it's a full size carrier. Not a bad lower unit. If you hoard engines like I do, you got more than a few. And, for my use, you want to, bring down the lower intakes, not the lower intakes, the intakes on the water intakes to just the lower two spots, because I'm never going to be running any of my boats, wildly out of the water like guys with a hydro stream do. Just getting them to the point where, I'm freed out of the water a little bit is plenty. So I'll probably add a tiny little cone of sorts to it, but not much more than that. There's really no need for, running the Delaware where it's just not a stream, it's not a lake, it's not flat. I'm not airing out a Allison. So what I do is you want to open up the two lower orifices bigger, because you're going to have to get all your flow through there. Now, I suspect I could get away with not doing that, but it just lets me, sleep a little better at night. So I open them all the way out. I port them to the 9th degree, which, again, it looks cool at least. And I'm just using a Dremel. Of course, the trick with using a Dremel is you want to keep it lubricated, so I always have that wax block. You want to run it the same way you'd run a, high performance CNC milling machine. Basically, you don't dig it in. You want to only cut with like just maybe 10% of the radius or less. So you're constantly moving the tool around a lot, but you're taking lots of light cuts. And that's what we do in the machining world now that we have, the complicated cam generating or computer generated tool paths. So I'm just working my way around piece by piece by piece. Again, hit that wax block. And, there's some guys who use other stuff. Some guys swear by WD-40. The wax seems to work fine by me. So you're going to just pull out that extra material. And then once you get rid of that extra material, it gets a little tricky in that I kind of like to dig in a little bit and kind of not just open the hole bigger, but I actually sort of relieve the back of the hole, because we're going to be putting that, it's almost like I don't want to say a net, but they come from the factory like a plastic, I guess it's like a filter of sorts. It keeps the, obviously lets water through, but it keeps you from getting too much sediment into the lower. So that actually has a lot more surface area than the holes in the lower. So because of that, it's like I'll dig the holes bigger, and I'll also dig behind the holes a little bigger so that I can, use more of that area. So yeah, it isn't lost on me that, you're using wax and then down the road you want to use JB Weld or some other filler. Now I kind of think that it hasn't ever been a problem, and I kind of, when I get to the point where I'm like at the end and I'm making relief cuts for bonding, I just, don't really use any wax at that point, and, you just make the cuts a little more gingerly. I mean, most of the wax is just going to get blown off the carbide anyway. Once I get done, clearing out those lower two holes that are going to stay open, I got to address the upper two holes that are getting closed. Now, the first thing I do is I just rough up the general area, because I'm going to be sealing these orifices off with a combination of epoxy and literally JB Weld. You don't have to get real exotic. This is not a real fancy application. So in order to get JB Weld to adhere, you got to get down to bare metal, and the rougher it is, the more cuts, the more grooves, the more nuances, the better it's going to apply. So I just open them up a little bit, chew them up with JB Weld, and also prepare it for the slugs that I use. What I do is I cut aluminum slugs. I just use a bandsaw. It's 1/2 inch aluminum rod, and that winds up being about the right size to go into those holes. Because if you don't have anything filling the holes before you go in there with the JB Weld, obviously the fill is just going to fall into the hole, and you'll never get that little plastic mesh strainer of sorts back into the lower. So I just quickly run around the inside of the hole just to get the bare aluminum, because the more bare aluminum you have, the better you're going to do for, bonding on and getting things to fit nicely. And then, I'm going back and cleaning up the lower holes. I'm not sure really why I'm doing that in a different order, but that's what I'm doing. But you always want to just have that surface real opened up. I mean, sometimes if it's real critical, I'll even open the surface up, put epoxy on it, and then keep, grinding on it with the epoxy there. So you're literally, as you expose aluminum, it's exposed underneath the epoxy, and it never even touches oxygen. But, I don't think anything on this lower, we have to go that crazy. So far, I've only run these in a semi-surfacing application, and I don't plan to really have these things, surface. So I don't think I have to get into any of the carrier pinning modifications that some guys talk about doing. I mean, as it is, it's hard to get those carriers to pull out when you got to pull them out. So you're talking about old seized together outboards. I mean, there's guys who have billet carriers, and in the back of my mind, I've thought about it, but it's not something I really entertain doing just yet. I mean, the reason that's a thing is because when you're running with the prop, completely out of the water, it starts to almost want a pinwheel on the surface, and your loads are no longer a twisting load. It's kind of more of a moment load. So it's like the difference between, if you don't want to break a bolt, what you do, you use an extension. Why do you use an extension? Not because an extension gives you more torque with your socket wrench, but because an extension makes sure that you're going to hold one end of the socket wrench with one hand, and then you're going to kind of lock the the rotation where the extension comes out your other hand. So all the force you're exerting on that bolt is a twisting force. You're never exerting any kind of pushing force, because that extra pushing force might be the difference between getting it to break loose or getting it to snap off. So that's a trick you always do. I mean, sometimes if you want to be really gingerly, you actually use a longer breaker bar, because with a longer bar for a given amount of torque, or if you can't support, the nut or bolt, you always use the longest bar you can get, because that way any force is always just more so a rotational force or torque, and not a pushing force on the fastener. So that's a little trick, but fingers crossed these lowers hold together. And I listen to the guys on Scream and Fly, and they seem to have pretty good luck with them. So I have some Mercury Alpha lowers that have the better 1.62 ratio, and they're also ratcheting, which for me isn't a big deal, having a ratcheting lower, because again, I don't think I'm going to be building any really wild, high compression motors that need that. And again, the designs I want to build, engine or motor braking really shouldn't upset that design. If anything, it should be like a virtue that you get off the gas and you have a braking system. I mean, I'm even toying with boats that have brakes. So that's my thought process there. Yeah, I'm just grinding away, and again, right there, it's just hit the web. Just for shits and giggles, I relieve the portion of the lower in front of the orifice that's staying. There's kind of because there was a hole there was a little bit of a web that sticks up, and it just looks cooler with it gone. So I first hit it with the little grinder, and then I go back with a full-size die grinder. That's, by virtue of having a bigger bit, kind of just leaves a nicer finish all the way around. So there I am, just cleaning up a little bit, and if I remember right, that bar I was using was kind of already, I think I had gotten the bar caked in with aluminum, so it was just almost working more as an abrasive bit than a cutting bit. But for this application, it did just fine. I hit it with a little bit of sandpaper just to clean it up ever so nicely. Not that I'm sure it makes a damn bit of difference in the real world, but a little bit of emery cloth, probably 80 grit, 120 grit. It's really not that critical. You know, this whole lower is going to get hit with at this point, it's already been hit with a real thick 2-part epoxy, which, you know, as long as you use something good, it's going to hold up until you hit something really bad, and then no matter what you use, it's not going to hold up. So when it comes to like jobs like this, I always have lots of spare, you know, cheap used secondhand, you know, 2-part epoxy paints or urethane paints, you know, anything, you know, good, you know, anything better than Rust-Oleum. And I'm not knocking Rust-Oleum, but any of the curing type paints is going to do fine. You know, you could go in there with, you know, anode aniline primers for aluminum, all kinds of, it's just needless. You know, a lot of that stuff, it makes sense if you're running in a commercial application, but again, this is just a quick and dirty lower unit, of which, you know, I got piles of them. So I just clean up as best I can, and you know, it makes me feel good. Again, I'm probably going over the top, and I use a angle grinder with a flap wheel to really sharpen up all the edges, and you know, just make the thing look a little better. You know, this one was pretty beat up. Some of them come to you and they look nice, and some don't. This one, it was kind of a little rough. So there's the aluminum slugs I was talking about. And what I do is, you know, obviously none of this is real precise. You know, I'm cleaning out the holes with a Dremel, and you know, it's not like they were precise anyway. It's only an investment casting. So you have the slug. It's a little on the small side, so I just bring it to the welding bench, scrap piece of steel, bang it on with a ball peen hammer. That kind of resizes it, and then you do that operation a couple times, and you know, hopefully you get it to where you can, you know, pound it and press it in. And, you know, you want a snug fit, nothing crazy, but snug enough that it's not coming out, not going anywhere on its own. And, you know, if you hit the lower hard enough that it comes out, well, you don't have a lower at that point. So once, you know, those 2 slugs are in there, good. And, you know, again, is this necessary? Probably not, but I'll go back with the little Dremel tool just to be fastidious, and I'll rough them up a little, and I'll also make little cuts and grooves around, you know, where they press in, and that way the epoxy has, you know, just that much more surface area to grab onto, and you know, the epoxy's also holding them in together. Again, going overboard, but it's just, I just have it in me. I can't leave well enough alone, and you know, I'm not going to do anything really to, you know, repair that fin. It is what it is. The bulk of the, you know, the fin is still there, and the application I have for this outboard, it's not really going to be a rear steered outboard anyway, so it should do just fine. If I remember right, the only thing that really gave me pause on the outboard was the drive shaft. Oddly, the splines were a little not chewed up. They almost look like, because almost like it was a real rusty drive shaft, and it almost looks like they were braided away. Like the metal was just kind of like from vibrating, it was just gone. Like not like they were physically like you over torqued and they went out, just that they just kind of wore off. So kind of a little confused by that. I've never heard of splines ever failing on an outboard, and I'm tempted just to kind of peen on them a little, just so when it, you know, sticks into the crankshaft when you install it, it just doesn't have any play in it. Because I kind of wonder if it was the play that was, you know, physically wearing it out. I mean, obviously I'll put it together with plenty of grease on it, and it'll probably be just fine. But yeah, you can see just how rough it is. And at this point, I'm going to go in there and just clean up those edges a little with that angle grinder that I talked about. And again, nothing exotic, just, you know, make it a little pointier. You know, it doesn't have to be a sharp point. You really don't actually want a real sharp point. But you clean it up, and, you know, it looks better, it makes you feel better. And, you know, you do your little damnness to, you know, make it nice. So, you know, obviously working on the opposite side, and, you know, that one's still got to get the plugs shoved into it. And on that side, you got that one, that Phillips screw. You never take that out unless you're taking the whole lower out. If I remember right, that holds one of the bearing carriers in place. So, and then, yeah, I didn't film doing the JB weld, but it's pretty self-explanatory. So there's a JB weld, and you sand it, and you're good to go. The end.